Okay, we're going to talk about quadratics in standard form, which quadratics, the other ones that we did, they were already in vertex form, so it was easy to tell the parts of them, but they're not always in vertex form. Sometimes they're in standard form. So if I have a quadratic that looks like this, I'm not able to tell the vertex by just looking at this because it's in a different form. So this is the form of ax squared plus bx plus c. So the first thing that I want to find is I want to find the axis of symmetry. Axis of symmetry is where you could fold the parabola in half and it's going to be right on top of itself. If you look at the parent function, where I would fold this in half is on the y-axis. If I fold it in half, it's going to be right on top of itself. So what would be the axis of symmetry for this is x equals 0. And it's the equation of this line right here, which means it needs an equal sign to be an equation, and it needs the x value, okay? So what we're really looking for is what is the value right here. If you had it in vertex form, it would be x equals h. But unfortunately, we don't have it in vertex form. So we have to do it slightly different. So what we're going to do for these guys is we're going to do negative b over 2a. So x equals negative b over 2a, which that's going to be the same thing as h. That's going to be our h value. So we're going to look at that. So what we're going to find right here is, on this equation, it's going to be negative 6 over 2 times 3 equals negative 6 over 6 equals negative 1. And I'm just going to rewrite the equation. The axis of symmetry, where I can fold this equation in half, or sorry, fold this parabola in half and it's the same on both sides, is x equals negative 1. Really important that I write it as an equation. Okay? I'll do a couple of examples of those really fast. Axis of symmetry here is going to be x equals negative b, which is negative 2, over 2 times a, which is 4. Negative 2 over 8, or negative 1/4. I'm just going to rewrite the equation right there. So it's fairly simple. Now remember that if you have a negative value, you need to keep that in there. You need to switch the sign. So if it tells me something like this, I'm still doing negative b. So b is negative 9. Negative b is going to be positive 9 over 2 times a, which is 3. 9 over 6, or 3 over 2. So it's going to be x equals 3 over 2. That's the axis of symmetry. So you're really just looking for that x value in your vertex. Now how to find the vertex? Well, we already found part of it. So what we want to do is we want to find negative b over 2a. That's the input. And then we want to plug it into the function rule and see what it gives us. So what this means is I'm going to take the vertex that I just found, take the h value that I just found and plug it into the equation. So I'm going to say f of 3 over 2 equals 3 times 3 over 2 squared minus 9 times 3 over 2 plus 4. Just going to go through the process. 3 times 9 over 4 minus 27 over 2 plus 4. This gives me 27 over 4 minus 27 over 2 plus 4. This is going to give me negative 27 over 2 plus 4, which is going to give me, that's the same thing as 8 over 2, so it's negative 19 over 2. So my vertex is going to be 3 over 2, comma, negative 19 over 2. And that's all you're doing every single time. You're finding the axis of symmetry, the h value there, and then plugging it into the function rule. So do another example. So first thing I'm going to do negative b over 2a. Negative b is going to be 4. 2 times a is 1. 4 over 2 or 2. So that's part of my vertex. Now I'm going to take the 2 and plug it back in. 2 squared minus 4 times 2 plus 6. 4 minus 8 plus 6. Negative 4 plus 6 is 2. And put that. And that's it. That's all that you're really doing there. So we want to find the axis of symmetry and we want to find the vertex. The last thing that we want to say is the vertex a maximum value or a minimum value? Well, maximum value means that it's the highest number that it can be. That's the highest value that your output is. Which if we're looking at our graph, a maximum value is when the quadratic equation gives you this. Maximum meaning the highest point is right there. So if that's what we're doing, then your a value equals negative. So you're going to have a maximum when a equals negative. A minimum is when it's the lowest point. So the lowest point is right there. So that's my minimum value. So minimums are going to happen when a equals a positive. And that's all that you're really looking for there. Okay? So really, if you're talking about your domain and range, domain on this guy, domain is the set of all real numbers. Range is y is greater than, less than or equal to the y value at your vertex, which is k. For this one, your domain is still all real numbers, set of all real numbers, but your range is y is greater than or equal to whatever the value is at k. And that's it. That's all you're really looking for there. So, pretty simple.